All right, we're alive. February 19th. Let's do it for today's LeetCode challenge. First, take a look at the notifications, if there's anything. Oh, there's something I remember I commented there. Oh, somebody commented here. All right, that's. All right, let's see. I should make calculations. Blah, blah. What did I say? I don't even remember what I said. What did I say? What, did I say anything? Another shorter. Oh, yeah, that's true. That's true. All right, let's see here. For honesty, just for the laws. Oh, he responded. So why in? I don't even remember this. Oh my god. X plus 5. What did you do? Oh, for X in. So we don't have to do the. We don't have to do this. Yep. For Y, S, and this. Or, oh my god. I know what this means. This is just I don't have to run the check on as alpha. All right, I don't have to do run on the check. I'm gonna upvote. And for X in this, yeah, this is for that. And then S, or if not S, we'll return this. All right, that's fine. It's understandable. Yeah, it's a good solution. All right, anyway, let's go into it for today. Minimum remove to make valid parentheses. It's a parentheses question, most likely involving stack, and I might have done this before. Maybe. We'll take a look. Given a string of left and right parentheses and lowercase, right, or lowercase characters, your task is to remove the minimum number of parentheses in any position so that the resulting parentheses string is valid and return any valid string. Okay? A parentheses string is valid if and only if empty string contains only lowercase letters. Okay? It can be written as AB, where A and B are valid strings, or it can be written as this, where A is a valid string. Yeah, it's actually, I think it's a recursive definition as well. All right, let's take a look. LeetCode, we're gonna remove this, right? Yeah, this. So the minimum number, okay. So remove one. Remove one. This has to remove all of them, and this have to remove and this or this. Yeah, I think, wow, this will be hard to test because I will only return one. Yeah, because like this one, I think I can return this, which is remove the first one, or I can return this. Yeah. So basically, if there's a mismatch, then you definitely can return. You can handle if there's a mismatch. I mean, it's basically mismatching, right? When the parentheses are not valid, that means there's a mismatch among the parentheses. I want to just take a look at a simple example. This seems too complicated. Let's take a look at this one, right? A right parentheses B, left C, right D. So if we're thinking about the general approach, which is pushing into the stack, we're going to push A in, and then a right parentheses. So when we push a right parentheses, what we do is we are going to pop out and until we find a left parentheses. So we're going to pop out A, and we probably have to push A somewhere else, and then look for, and there's no left parenthesis, which means this one is wrong. This right parenthesis is wrong. So if it is wrong, then we remove it, and then we keep going. B, left parentheses, C, right parentheses, pop out C, and we see the left parentheses pop out both, and D, and then we good. That means we remove one. All right. We can do this, but how are we sure that, how can we be sure that this is the right approach? How can we be sure that it is the minimum number to remove? I mean, let's look at this one. These are regular letters. We don't even have to push regular letters because all we want to know is the parentheses, if the parentheses are good. So we don't even have to push. So we push this, and we push this, we push this, and we pop them out. We push this, popping them out, and finally we push this in, and then we check. And when we check, we realize that this one, we don't even have to check. We push this and find out that it's an empty stack, so this one must be wrong. So we note that this one is wrong. Okay, that is good. We know about this. How about this? We're going to deal with this the last. We push, push, push. We push 3, pop 1, and we end. And we find out that there is an invalid left inside. So we say that one is invalid. We're going to remove it. Okay, that is good. Now, tell me, they have like the length, 10 to the 5th. 10 to the 5th. Okay. So it's ON, so it has to be like one pass. Is that definitely giving, I mean the minimum number, right? Minimum number, if we remove, right? We remove all the letters and they only have parentheses left, and we run this trick just to check if the parentheses make sense. And when we run that, we will get rid of all the valid pairs. So the only ones remaining will be the invalid ones, and those should be the ones eliminated. Yeah, because when we do this trade, the stack thing, we are validating the parentheses, and we are actually trying our best to maximize the number of parentheses available in the string by assuming all the parentheses are valid to begin with, and then we're trying to see, okay, whether this hypothesis stands. And as we validating all the pairs, all the valid pairs, the things left should be the minimum number of parentheses to be removed. All right, finally, let's take a look at this. So we have the right parentheses, that's wrong. That's wrong, so we know these two cannot be inside. And this one we push in, this one we push in, and we end. And then we look at the stack, we see these two, so they must also be wrong, so we need to remove them as well. All right, so now we know what to remove. Now the problem is how do we produce the string, right, after we remove? Well, the idea that I was thinking about is we can push in not just the parentheses but also the index, so we know which index shall be removed. But it seems to me that it is actually possible to directly construct the answer. So I'm going to go with this one again and see if it's possible. So like the idea we had before, we push, so we find A, then instead of pushing into the stack, we push this into the result because we know A is a letter, it will definitely be in the result. And then we have a right parentheses, we push in, and then we find that the stack is empty, so this one must be wrong. So we don't push into the result. Now B comes in, B go into the result, and now a left parentheses, we push into the stack. A C, we push into the stack. And a right parentheses, we don't push into the stack, but we need to pop. But if we pop and push into the result, then we cannot push in the left parentheses. So that means whenever we have a left parentheses, we need to, we have a left parentheses. That means that we have to push into the result. And then we have C, and then we have a right parentheses. Then how do we check? We cannot check. This idea of directly producing it seems to be a little bit difficult, because we cannot handle the left parentheses. The left parentheses has to stay in the stack for the right parentheses to arrive. So how do we deal with it? How do we deal with it? I mean, if we, let's try to get this to work and then think about it. To get it to work, we'll just figure out which one to pop, which parentheses is wrong, and then we're going to reconstruct the string by tons of concatenation, which is still O(n), so I think it will still pass, but it probably has bad time. But we're going to see about that. So let's just give it a shot with our current understanding and see if it works. Again, I feel like it's hard to test because it says you can return any string. It's not just like one string. So we will still try. So the idea, okay, let's do this again. So we're going to have a stack. Right, when for I letter in enumerate S, and if let is a left parentheses, then we stack always push, not push, append. Elif is a right parentheses. Then we need a stack, and we need a removed. There's also going to be a list. So when they say if stack and stack top is a left parenthesis, that's a valid, so we say stack dot top. Right? We are good. Else, which means either not stack or the top of the stack is not. Well, the top of the stack is only possible because we're not pushing all the letters. So the top of the stack, the only possibility is a left parentheses or nothing. So we don't even have to do this. We just say if stack, we're going to do stack.pop, and if not, we're going to do removed.append I. Actually, when we append, we shall append only the I. Stack.append I, because we know on top will always be the left parentheses. So we need to put the left parentheses index in it. And we're going to do stack.pop and then removed.append, right? And when this whole thing is done, we have stack and removed. Anything in the stack and anything in the removed will be the parentheses we need to remove. Now we need to remove it. How do we remove it? We are going to, that's actually a better idea. We can make these into set, right? Actually, we can be this. And we just going to be like this. Result is this. I'm going to say for I letter in enumerate S again. We actually, result is this. And total removed. Okay, removed index will be set stack plus removed. And then we're going to say if I not in removed index, we're going to do res plus equal letter, and we're going to return res. All right, we're going to run a little test on this and see if we pass. So what do we have? We have this. We have this. Oh, what the hell? And the return value, the way that we are doing it should be this. And the next one, we have this. And the return value is this. Forgot again. Next one is this. Probably faster just to type it. This one definitely faster just to type it. All right, last one will be this. Let's just copy it both. And then we're gonna basically manually parse it. Yeah, like that. Good. All right, change S is good. Okay, minimum. All right, take a look. We all pass. Let's run a few edge cases in here. Actually, I don't even have edge cases. I don't even know. Left. All right, I'd just submit it. I don't know. I have good faith in this. Yeah, we got it. Yeah, it's this is exactly how it is. Because this process of checking whether the left and right parentheses they match is actually trying to push to the maximum matching. So whatever cannot be matched must be removed. See, it shouldn't be too bad. I think we can only go once. We have a little bit cost here. We are at 71%. Not bad, not bad at all. So here is the solution. We run the generic stack operation to check the validity of all the parentheses in the string. We do not have to push any letter into the stack, nor the actual parentheses. We only need to push the index of the left parentheses into the stack. Whenever a right parentheses appears, we check whether the stack is empty. If it is not, then by the rule of the operation, we can be sure that the top of the stack must be a left parentheses. We have a valid match and we can pop this top of the stack. If the stack is empty, that means the right parentheses is wrong, is invalid. Oh, I don't even have to do this. I can, yeah, I just realized. Removed could be a, yeah, but that's fine. Could be a set by itself, so we don't even need this. So at the end, we just merge stack into it. Yeah, let's do this. I think this one can be a set by itself. So we just do add, and then we can say removed dot union and set stack. I think it should work. And then we here just say removed. It is not okay. All right, so I think it has to be removed equals. There we go. Oh, then, oh yeah, this has to be. Okay, where are we? It means the right parenthesis is invalid, and we need to note down its index. At the end, any in any left parentheses left in the stack are also all the invalid. Put together all the invalid indices, and based on that, we can produce a valid string. And we have on. It is also worth noting that since the parentheses validation procedure naturally assumes maximum number of valid parentheses. Any invalid parentheses it finds are the minimum number of parentheses to remove. All right, so it's on, and we scored a 116 milliseconds con 61% ranking. Okay, so that's that. We're happy. Take a look at this. Nothing important. Solution is not available. This, I don't know. Is this a easy problem? Could be. I don't see too much twists and turns. Only one. I think it's a medium. Yeah, it's a medium. All right, we did it. So we upvoted 1,240. It must appear in one of the contests. Sometimes I need to get back to the contest. Yeah, I haven't done it before. All right, let's see. Any people that we respect? Not really. Actually, I saw this guy a lot of times. Super simple solution. This is a clickbait, huh? Python stack, Java Python solution. All right, let's see. All right. Oh, I think this is exactly our solution. I mean, Java and C++ is pretty much the same. Push I, yeah. If it is, if not in, pop else. It's I equals, oh. Oh. Oh, erase. Huh. Track indices. Delete at, oh, so the same. Placeholder. Does it have placeholder too? Ah, good use. Yeah, that's the one I was thinking about. Yeah, I'm gonna switch it to this. Not bad, okay. What do you think? It's the same. So, but I do like this. I do like this. I think it's this. Yeah, yeah. Oh, nice. Good use. Oh, one. It's set. Yeah, it is set. Good. All right. So we come up pretty much the solution. Well, stack. Ah, so just like different ways to reproduce, this the S. Oh, this oh, it's not the same. It use less memory. Use less memory. We have a set. This doesn't even use a set. We just set these two. Yep. I like this one. I like this one better. Should we implement it? I mean, it's pretty simple to implement. Let's do it. I like that solution. I like that solution. It's very simple to implement. Basically, it's the same thing. So we can actually copy and paste a lot of the code that we have. Just copy and paste everything, but it's not going to be exactly the same. Basically, we're going to say slist equals list s, and we're going to do this. Instead of having a stack, we are going hold a sec. Hold a sec. We still need a stack. We still need a stack. We still need a stack. Stack still has to hold it. And then it's just one this, and this is instead of remove, we say slist I equals, yeah. And we don't need this. We just need for j in stack, say slist j is empty. Actually, I can use I again. New thing. And then we're going to return dot join slist. And let's make it even more annoying. Put these two in the same line. All right? And we run solution 2, and it passed. Okay, we can say the same main concept, but less memory use, because we do not need to establish, create new sets to hold the invalid indices. Instead, we simply reset the letter. We set the invalid parentheses to an empty string and use join to recreate the valid string. Good solution. And then we put in the reference, give them a reference. It does work, right? The clickbait. Yeah, I'll have to run it as well. It's not going to be. Actually, I'm going to copy and paste the entire thing. Submission. Oh my god, give me more room, man. And submit. Would it be faster? Oh my goodness! Holy moly! Oh wow! Oh wow! Oh! It shaved half the time. Yeah, because there's no add. Because you add to a. Oh man. Oh wow. This is. Now I see the value of this. Exactly. Oh wow. I need to. Oh wow. Yeah, this is good. On and it ran in the 68 milliseconds, and we get a 99% ranking. All right, I am initially shocked by the performance, but come to think of it, it is understandable. Double, because this solution has no uh, extra operations with uh, with a set. Every time we add something to a set, although it is O1, we still have to not we, the system still has to compute, still has to manage a hash map, and that takes time. And this solution completely avoids it, hence it is super duper fast. Yeah, wow, this is good. And it saves memory as well. Yeah, plus it saves on memory as well. My goodness, I did not expect this one to be this good, but holy cow, this is good. All right, I'm very happy with the solution. Especially, we almost got all of, I didn't, why did I not think of this? It's actually, in hindsight, it's very obvious, but oh man, this is good. This is very good. Anyway, yeah, that'll be it. That'll be it. We had a good solution initially, and we improved upon it by reading one of the comments, and it's very good. I am happy. All right, let's stop right here, and tomorrow might be a hard one, and we need to get ready for it. That's it. Bye. Adios.